All right, guys, today I'm going to go over Firestarters 28. So remember, this is actually 28. I'm going to go over Fires 28, 29, 30, and that's it. Remember those ones? So remember, Firestarter 28 is kind of like they're telling you there's only one more bit of information you would need, and then you could use the following statement. So they're telling me I have to be able to use side, side, side. All right, so they say you have to be able to use side, side, side. I look and see that I have a side congruent to a side. So there's one side right there. So this is what I have. I have QR is congruent to BR. If I was writing my proof, that'd be my first side statement. Now then, I would, without knowing any more information, I can say that PR is congruent to RP or PR again, because that's reflexive property, so I don't need more information for that. So the one statement I actually need, I need them to tell me that this PQ is congruent to PB. So this is the one I need. I need PQ is congruent to PB. So that's the one statement we need. All right. That's it for number one. That's it. Segment PQ is congruent to segment PB. So I look at number two. This is given, so I already know that LM is congruent to UM. So that first side is taken care of. Now, without any work, I don't have to be told this because I know vertical angles are congruent. I can say angle LMN is congruent to angle UMW. That's given. It's not given. It's because vertical angles are congruent. Vertical angles theorem. But I don't have to have any given information for that. So what I would need this and this. I would need NM is congruent to WM. So that's the one side I would need. And I remember I need that one because the little blue arc for side angle side has to touch both congruent sides. So the little blue arc, right here, this blue arc right here, has to touch the side here and the side here to be in between location-wise. All right. So I have my 90-degree angle, and I know my 90-degree angle is right here because of vertical angles. So I already know that the measurement of angle WXV is congruent. I'm sorry, not congruent. We're using equal because we're saying measurement. Measurement of angle GXH equals 90 degrees. That's big, huge, because that's one of the things we need for hypotenuse leg. Now this right here is a leg statement. So I have WX is congruent to GX. Now what I don't have is I don't have this one. So I need WV is congruent to GH. So that's what I need. That's the one statement I need to make this true. All right. All right, number 4. So this one I have to have angle, side. So I have to have two angles and a side. So I already have one set of angles right here. So I have angle GEF is congruent to angle. So I went G, which is on the corner of one dash or two dashes and no dashes. angle MKL. Now I also know these sides are congruent. So I have an angle, I have a side, because I have GF is congruent to LM. So I need one more angle. I know I need another angle. And really I need an angle that's going to put it next to, that's going to be, and actually in this one, it really doesn't matter which angle you pick. If I pick this angle right here, that's going to be angle side, because the congruent side is only touching one of the angles. If I pick this angle here, it'd also be angle side, because it's touching one of those. Now, if I rotated the left triangle 90 degrees counterclockwise, that would take the E on the bottom, and it would line up, it would be the same orientation. So E goes with K, right? F goes, or is with M, and G is with L. So you need to know which angle you're going to be picking to when you make this, so you make sure it's done correctly. So this one's probably the hardest one because the angle side. So I'm going to pick G, right? So G is with L. Now notice, I'm allowed to pick this and make angle side because there is only one congruent side. Look, if I look at the blue side, remember, this is what I mean by location matters. This blue side right here is only touching one set of congruent angles. This blue side right there is only touching the green set of congruent angles. It's not touching the purple set of congruent angles. That means it's angle side and not angle side angle. That's important. All right. So I'm going to add one more line. We're going to say angle, and this is the line you need. This is the line that you weren't given. EGF is congruent to KLM, angle KLM. So this is the line you're looking for. All right. Finally, last one. Look, you're already given these two sets of angles, so we know, and this is actually how I would write it out without explaining everything every time. I would say, look, that's an angle right there. I would say that's an angle right here. So I have my angles. The only side I can pick is right here, because those sides were the only sides that are going to be touching both the congruent angles and make it angle side angle. So really the only thing I need for this one is FG is congruent to RQ. Done. That's it. All right, Firestarter 29, really easy. I'm just going to add a picture. It's going to make things super easy. All right, look, so the least amount of sides you can have on something is 3 for a triangle. 4. So biggest mistake I see in 4 is people use like brand names like square or rectangle. Those are like brand name quadrilaterals. Those are specific. You have to know more than the amount of sides to know if something's a square or if it's a rectangle. That's why it's not the name of all the polygons. The polygons has to say, as long as it has 4 sides, no matter what, it's quadrilateral. You can't say square or rectangle because those are specific to congruent sides or measure of angles. That's why it is not square or rectangle. Most people get 5, pentagon. 6, a lot of people understand, have heard of hexagons. 7, we go heptagon. Sometimes people will say septagon. It depends on like the math teacher themselves. I'm fine with either way, but I think when I was in school, my teacher liked to use septagon, but it looks like some people are using more people are using heptagon now. 8, octagon. Lots of people know about octagons. Those are your stop signs. 9 is a nonagon. 10 is a decagon. 11, I don't know if we'll ever use this, but it's called a hendecagon. 12, dodecagon. And then we have n-gon. There's more. You can really... So n-gon would be... And if you want to look up 20, 20 is a good one. It's a Hexagon. And that's it for the first one. All right, to classify polygons, you have to go through three things. So the first thing you're going to talk about is you're going to say the polygon name based on the number of sides. That's important because we're not talking about like, we're not going to say square or a rectangle because we're only worried about the number of sides. All right, then we're going to talk about, you're going to say convex versus concave. Convex means, basically the way I kind of explain it is it looks like it's full. There's nothing dented in anywhere. There's a math way to say it where if the segments were to extend, they never go inside the polygon itself. But basically, as long as all the sides are like not dented in is the way I think of it, or not caving in on one side, it's convex. And the last thing you need to do is you need to tell me if it's regular or irregular. Because remember, regular means we have all congruent sides and all congruent angles. All right. Irregular means anything but that. Regular also means it has to be convex. So you cannot have a concave regular. That's impossible. All right. So number one, really simple. I'm going to count the sides first. 1, 2, 3, 4, 5, 6. So right away, number one, I have a hexagon. Now I'm going to look and see if it's convex or concave. Now see, are these two, those look like it's like dented in there. That makes it concave. And like the math reason would be is like, imagine those side lengths went on. See how like technically the dotted lines would go inside the shape. That means that it is concave. Now, remember, last one we're going to do is regular versus irregular. As soon as I write the word concave, I immediately say it's irregular. All right. Sometimes they don't write irregular; they just write nothing. All right. They only add, but today we'll put irregular. So then we go on to number B. B says count. We're going to count the sides 1, 2, 3, 4, 5, 6, 7, 8. So we have an octagon. This is what I'm using these names from the previous Firestarter. Now I look and say all the angles are congruent, all the sides are congruent, and most importantly, before I do that, I see that it's full. There's nothing dented. Basically what it means is if these sides were to go on forever, none of them would go inside the octagon itself. That means it's convex. Basically, like I said, the easiest way for me to look at it is basically, does it look full? So it's like, does it look like it's full? Like there's no flat side, there's no dented insides. So that means because of all the congruent sides and angles, it's regular. So this is a regular octagon convex. And really, if you write regular, convex is kind of implied. So some people won't write both convex and regular. Some people will. Depends. I'm going to have you write both. C, we're going to count the sides to start. So look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means it's a decagon. All right. Convex or concave. Well, look, those two sides right there, each of those sides look like they're dented in. So we're going to say concave. Remember, as soon as I write the word concave, it immediately means irregular, even though we have a lot of congruent sides and angles. All right. D, Remember, it is not a rectangle, even though it is technically a rectangle. It is a quadrilateral. Two, it is convex. And even though this is a rectangle, and everybody thinks it's regular because a rectangle is like a fancy brand name, it is not regular because it does not have 4 congruent sides. It has 2 sets of congruent sides. So it is actually irregular. Believe it or not, it is actually irregular. Last one, E, we have a hexagon. It's got 6 sides. It is convex, because there are no dented sides, and all the angles and sides are congruent, so it is a regular hexagon. And that's it for the Firestarters.